Morning all, Mr. Yates here. So today we're going to be having a look at a few exam questions from the 2018 exam. Now you can get access to this one by going on to Connect and looking in the Library tab, and that will have a whole bunch of different exam questions, including the one we're going to be looking at today. Now, let's get right into it. Now, I am recording at school today instead of doing that at home, so unfortunately, Smeagol will not be joining us today. But maybe in the future he might be back in if I do happen to be recording from home again. Anyway, here we go. So this is our Tuesday lesson for week 9, and we're going to be having a look at the 2019 exam questions. As I said, we're going to look at 3 calculator free exam questions and 3 calculator allowed ones. One of the other things about the calculator allowed section is that is the section where you are allowed your own notes. In the calculator free section, you are not allowed your own notes. You are only allowed the formula sheet that is provided to you by us. And in the calculator allowed section, you are allowed your own formula sheet. And obviously you're allowed your calculator as well. Now they do expect you to have and use your calculator, and they expect you to have and use your own formula sheets and your own work that you've done as well. So, and we'll see a bit of that as we go through these exam questions, definitely. So, now I would encourage you to go through these questions yourself before I actually go through and give you the answers. So I'll leave these up here for a bit. Definitely have a shot in your own workbooks on these questions before I give you the answer. Remember that we do have a number of marks that each one's worth. So that should give you a rough indication of how many minutes you should spend on any given question. So for a 2-mark question, you're expected to spend around 2 minutes. For a 3-mark question, you're expected to spend around 3 minutes. Now you may end up spending a lot less time than that, and that's good. That's time in the bank for when you want to attempt some more difficult questions. Remember that not all questions are created equally. So some questions you'll need to do a lot more work for your 2 or 3 marks than you will for other questions. So you've got to make sure that you're prioritizing your time when you're doing an exam. Now this session will probably be a bit longer than most because there's a lot of stuff that I've got to get through with this one. But see how you go with it, and if you want to stop it and come back to it to it halfway through, then that's all fine, just so long as you're having a look at these and making sure you're giving these exam questions a shot. So first up, we've got a fairly straightforward solve an equation. It's a linear equation, so it's not going to be too difficult. There's only going to be one solution. So let's have a look. So obviously we got solve 5 brackets 2t plus 1 close brackets, subtract 3 brackets t minus 4. Now there is one big trick with this one, which I'll get to in a minute, but we just want to expand these brackets. So obviously we do 5 times 2t, which is going to be 10t, and then we do 5 times 1, which is plus 5. Now remember that this in the front is not 3, it is negative 3. So we've got to do negative 3 times t, so that's take 3t. And then we've got negative 3 times negative 4, which ends up being plus 12. That's the one that would end up tricking you if you weren't paying attention. Then we just combine our terms. So 10t take 3t, so all equals 0. 10t take 3t is 7t. 5 plus 12 is 17. So we've got 7t equals negative 17. T equals negative 17 over 7. So I would expect that to be our answer for that one. Just give me a moment just to make sure I'm not doing something completely off the wall. Yep. So I do have the answers up there as well, so you can have a look at the answer key online, and it will tell you exactly what you need to do to get these points. So the one that would have tricked people up is this negative 3 times negative 4 being a positive number. That's something that gets people a lot, so it's fine if you didn't get it. And also we didn't have an integer solution, it ended up being a fraction. And that can start to confuse a lot of people, understandably, because a lot of the time when we do these kinds of questions, we expect to get a round number or an integer answer, but we haven't got that here. And in this case, this is still the correct answer. So our next one here. Now this is another linear equation, and we've got to do something a bit special to solve this one. And they've given us a little bit of a hint in that they have made it subtract one fraction, subtract another fraction. So what we can actually do is we can turn that into just 7 over a take 5 equals 3 over 4a. Now remember, when we're solving equations, we do not like fractions ever. We want to get rid of these whenever we can. So what we actually do is, and I like to put brackets around any terms like that, just to remind me that what we've actually got is not, we cannot separate out the a and the negative, or the a take 5 from each other unless we do them together. So what I'm going to do is I'm going to multiply the whole thing by a minus 5. And if I multiply the whole thing, that's multiplying both sides by a minus 5, I get 7 brackets. Oh, sorry, I don't get brackets at all because the a minus 5 cancels out. So I've got 7 equals 3 brackets a minus 5 over 4a. And then I multiply the whole thing by 4a. That's both sides. So I'll just sort of indicate that we're definitely doing it to both sides. So we multiply by 4a, that cancels out the 4a on the right, and on the left we have 7, I'll get that in blue, 7 times 4a equals, and that one just cancels out, 3 brackets a minus 5. I can expand and simplify those. 7 times 4 is 28a. Equals 3a minus 3 times 5 is 15. I add 15, oh sorry, no, don't add 15. I subtract 3 from both sides, I get 25a equals negative 15. A is negative 15 over 25, which is negative 3/5 when we simplify it. And I'd expect that to be my answer. So negative 3/5 would be the answer for that one. These are some fairly straightforward linear equations, but we're just got to make sure we're being careful with how we multiply, everything like that, that we're multiplying by this entire a minus 5 there, not just the a or just the 5 there. And remember, we cancel that out. Or another way we can visualize this is we're basically bringing this one up onto that side and bringing that one up onto that side is what it looks like we're doing, even though we're multiplying both sides by a minus 5 and multiplying both sides by 4a to be able to make that happen. Okay, so now those first ones were linear equations. Two ones are quadratic equations. The thing to remember about quadratic equations is that they usually have 2 answers, or two at the most answers. Sometimes one answer, sometimes no answer. But we'll be able to see those when they come up. Okay, so give these ones a shot, and then I'll go about solving these. So pause the video, have a shot at these ones, see if you can get all of it, and I'll go through the answers now. So, as I've mentioned before, when you are solving a quadratic equation, we always want to set it up so that we have got 0 on one side, because then we can easily use our zero product rule to work out that when we use the zero product rule, we can work out that the entire thing is going to be equal to 0 if one of our 2 brackets are equal to 0. Now in this case, this is a really easy situation that I've mentioned before. This one is where we don't have a constant term, and that means that x is our common term. So I can take that out. And in fact, it looks like that we can take out a 3 as well, but we don't really need to. Let's imagine we don't. We didn't spot that we could take out the 3 as well. It will just be 6x take 3. Now, what are my answers to this to equal 0? So either this term on the left would be equal to 0, or this one in there would be equal to 0. When's the one on the left equal to 0? Well, when x is equal to 0. So x equals 0. And where's 6x minus 3 equal to 0? That is when x is equal to a half. Because 6 times, or half of 6 is 3. 3 take 3 is 0. So those are my two answers there. If I did take out the 3, I would have ended up with 3x brackets 2x minus 1 equals 0. And that would have ended up with the same answer. X would be equal to 0 or x would be a half. And but yeah, that's the answers that we're looking for there. Cool, pretty straightforward. Next up, again, I have a situation where it's not equal to 0, so I want to change that so it's equal to 0. And I also want to expand because we're going to need to work out the solutions and we're going to need to use our zero factor law, or zero product law. So we're going to need to factorize like we did in the equation above. So let's expand that. That is x squared plus 2x. And we're bringing this 24 over, so it'll be minus 24 equals 0. Now we've got to think to ourselves, what two numbers multiply to negative 24 and add to 2? So one of them is going to be a negative number. That's the only way we get a negative 1 when we multiply the two together. So our two numbers, have a bit of a think about this one. Our two numbers actually end up being 6 and negative 4. So 6 times negative 4 is negative 24. 6 plus negative 4 is 2. So we end up with x plus 6 and x minus 4 equals 0. But that isn't our answer, by the way. Remember, we've got to find out when this whole thing is equal to 0. So when's that going to be equal to 0? That's going to be equal to 0 when x equals negative 6. When's this other one going to be equal to 0? That's going to be equal to 0 when x equals 4. So our two answers, let's separate that out a bit. Our two answers are x equals negative 6 or 4. And that's our answer there. So x equals negative 6 or 4. I'll highlight these as my solutions just so it's completely clear that that is what I've got there. So that's our first questions, question 1 and question 2 of the calculator free. Now that was, let's have a look. Oop. So this one was worth 5 marks, the other one was worth 5 marks. That's about 10 minutes worth of work. And if you know what you're doing, you could definitely knock that out in much less than 10 minutes. Now we're looking at square root functions. So give these ones a shot. I'm going to leave these two up, and then we're going to have a look at the bottom one. And in this one, we're going to be sketching. So you've got to make sure that you're fairly confident with your sketching here. And I'll be going through how we go about sketching. I've done it a few times in class, but it's always useful to get a bit of practice. Okay, so we've got a function, f of x equals the square root of 3x. So we want to calculate f of 12. That basically means we want to take that 12 and put it into the place of x. So what's the square root of 3 times 12? Well, 3 times 12 is 36. Square root of 36 is 6. 1 mark, easy done. Shouldn't be hard, it's only worth 1 mark. Now this next one, state the domain and range of f of x. Now this, just going to be a quick sketch. This is a square root function and it hasn't been moved around anywhere. It hasn't been moved up or down or left or right. It's just been basically dilated vertically by a factor of 3. So what we'll end up with is something that looks a little bit like that when we get round to it. So the domain is actually going to be any number that is positive. So the domain, can x be 0? Yes, it can. So x is greater than or equal to 0. And the same can be said for the range. Now, it's good to use the proper notation. The range is f of x, and that is also going to be greater than or equal to 0. So that will be what we need to do because the range is that one there. We can never have a negative number in our square root, at least not while we're in the real domain. So we're just going to say that the domain is x is greater than or equal to 0, and the range is f of x is greater than or equal to 0 as well. So next up is sketching it, and I've already done a rough sketch there. Now, when we're sketching, it is really important to make sure you've got the points that you've seen previously. So here, I knew that when f of x is, or when x is 12, f of x is 6. So that right there is a point that I can put on here. And this shouldn't say y, this should say f of x. Oh wait, no, it does say. This sketch the graph of y equals f of x. So that's all valid. So x equals 12, y equals 6. We also know that if it's 0, it's 0. And we should be able to find another point that might help us out. And remember, we've got, so y is equal to f of x, so y is the square root of 3x. Now, one of these at x equals 3. 3 times 3 is 9. The square root of 9 is 3. So at x equals 3, y is going to be equal to 3 as well. So we know it'll pass through this point as well. And we want to try and draw a smooth curve that happens to pass through these 3 points. So there's my very rough curve. It doesn't need to be perfect, but it does need to be smooth. And you do need to clearly articulate the important points. So these 3 points are going to be important, and they're what you're going to need to write or point out in order to get your 3 marks there. Your line doesn't have to be perfect. This could be more vertical than I've drawn it here. It could be straighter, but you're not doing, this isn't an art competition. We're not trying to draw the prettiest line we possibly can. We're just trying to get the idea across. You're trying to demonstrate what you know, not how steadily you can draw a line. Anyway, that's that one. So if you've been keeping track, then you'll know that we are now done with the calculator-free part of the questions we've got here. Now that is 6 and 5 and 5. That is 16 marks out of the 50 odd. So this is close, or just under a third of, or maybe a third to a quarter of what the exam will comprise of. So that's basically good to know. We've covered all this stuff in class. We should be able to do it. Hopefully there wasn't anything too surprising for you. Now, next up is our calculator aloud section. Now, calculator aloud does mean you can use your notes, and that becomes very important when doing these kinds of questions because your notes will really help you out. Now, this one is, I quite like this question because it covers something we first talked about when we started talking about quadratics and parabolas. And that is that there were 3 ways to draw our parabola, or 3 ways to write out the equation for our parabola. We had this form, which I called expanded form. We had this form, which I called turning point form, and this point form, which I called x-intercept form. So, and what do we need to do? We need to, I'll just scroll down a little. We need to determine the value of the constants a, b, and c. And that is, a is in the blue one, b is the green, and yellow is the red. Oh, yellow is c. So, let's see if we can match up these 3 lines to the particular coordinates that we have. So, first up, the easiest one, and you should not do these in order from left to right because there is one that is definitely easier than the others. And give yourselves a shot, give yourselves a chance to do this just before we get started. So the easiest one is absolutely this one right here. Because it's got a turning point of 2, 1. Which one has a turning point of 2, 1? It's this one right here. So this is our first parabola. Let's have a look, see if we can work out the rest. This one over here, that has an x-intercept of -3, 0. So the one that passes through -3, 0, here it is here. That's our second parabola, which means that this is our third one. So let's start solving these. They're not all the same difficulty to solve. I'll solve them just in order though, because this one is actually incredibly easy to solve. We're trying to find the y-intercept in here. So that's just that point there. So when x is equal to 0, the whole thing is equal, the whole thing zeroes out except for the c component. So we've got c equals -1. Easy, straightforward. I'll do this one next, B1, because B is pretty easy as well. We're just wanting to find the other x-intercept of the green line. So we've got -3 and we've got 1. So B is going to be -1. Remember that we subtract off that one. So that would be -1. This one's probably the hardest, but still not too bad. What we want to do is we want to find out we basically want to substitute in a point. So let's try and find a point that we've got. We'll just use the y-axis. Oh, sorry, yeah, the y-axis here. So here x is equal to 0. So and this is going to be the most difficult one to do. So what we've got is a times. Remember that x becomes 0 at the y-axis. -2 squared plus 1. And we know that that happens to be equal to 0 because we can see it on the thing there. -2 all squared is going to be 4, but we've got the a in there as well. 4a plus 1 equals 0. A is -1/4. Does that make sense? Well, yeah, because it looks flatter than these other two ones. So it's being multiplied by a quarter, which sort of flattens it out a little bit. It is pointing down, so we've got a negative number there. That's what we expect. So this all looks to be good for our answers there. So yeah, that one wasn't too hard. And for 4 marks, you should be able to do that pretty quickly. And if you weren't sure, this is the calculator free part, so you can always sketch those lines out as well. Next up, this one is worth 7 marks, so that's going to be quite a few marks for this one. It is a fairly complex one. Give it a shot yourself before we get started and I give you the answers. And let's go. So we've got two graphs. F of x equals 4 over 3 take x. And we've got g of x is 1 over x plus p plus q, where p and q are constants. So now, the first thing it wants us to do, or it's telling us that y equals g of x is shown below. So this is our y equals g of x there. So what it wants us to do is sketch the graph of y equals f of x. Now, one of the best ways to do this, if you're not exactly sure what to do, is to just sketch it. So I'm just going to put it in here. Let's get a fraction, 4 over 3 take x. So remember, this is calculator free. You should calculator aloud. Sorry, you should absolutely be using your calculator when you can. What have we got here? I like to look for intersections. When x is 1, y is 2. When x is 2, y is 4. When x is 3, now this is going to be our 0 point, so that's going to be our vertical asymptote. So that looks good to me there. I'm just going to draw that in just for, just so it's there. And so anyone marking the test knows that I have at least some idea of what I'm talking about. Looks like it goes through 5 and -2, 4 and -4, and so on. So what we expect to see, and we want to find out when x is equal to 0, that's going to be 4/3. So we just look at, because x zeroes out, we get 4/3. and that gives us our y-intercept. That's going to be an important point. So I will draw my asymptote. It doesn't have to be perfect, but it does have to go through any points that I've clearly indicated. And we want it to tend off to a horizontal line, or tend off to the x-axis. So that's what we've got there. So that's all we'd really need to do. And because this is calculator aloud, we can really use that. Now what's actually happening here is we've got a negative x, so it's been flipped upside down. It's got a 3 in there, so our asymptote is going to be when x equals 3. And the whole thing's being multiplied by 4, so it's going to be stretched upwards by 4. That's how it's going to compare to the standard reciprocal of 1 over x. But basically, by graphing it and looking at our points, then we can be completely confident that we're looking at the right thing. And yeah, we can start to label these points if we want to as well, just to make sure we get the full marks. So what are the values of P and Q? Well, we've got to have a look at where the asymptotes are for this particular one. And where are they? We've got an asymptote basically at these 2 points. And if you've got your own ruler, you can draw those in and just basically double check. So the vertical asymptote is at y equals -2. So basically it's being shifted to the left by 2. To shift it by the left by 2, we've got to add 2 inside the brackets, as it were. So P is going to be equal to 2. What else has been done? It's been shifted down by 3. So Q is going to be equal to -3. If you're ever not sure about that, you can write it in here. And I'll just do it in here above this one. 1 over x plus 2, take 3, and I'm just going to put that in here, see what it does. Does it match what I've got? Yes, it does. So it looks like it intersects between 4 and 5 there. Between 4 and 5, I've got that intersecting. Intersects between -2 and -1. That's where I've got this intersect on that side. Even if my sketch isn't perfect, it's good enough. So yeah, so I can be fairly confident that P is 2 and Q is -3. So you can always use your calculator to sketch these if you want. So now I've actually given myself I've made it so it's very easy for me to solve these, because what I've got to do is I've got to find where these two are equal to each other. Now I've already sketched both of these in my calculator. So what I need to do is just do gsolve, and I've got 2 things graphed on there, and I need to find my intersection. It wants it to 1 decimal place, so let's have a look there. And we're only interested in the x value. We are not interested in the y value. So we just want to find what the x values are. And that is going to be x equals -1.7 because it's asking for 1 decimal place. I can push the right button, or 4.4. So it's only asking for the x values for that one. So that is going to be our answer, and that looks like it's about the right things on these ones as well. So that's good. I'm happy about that. We would be expected to sketch that for that answer. So that's that one there. Let's have a look at question 13. So have a look at it, give it a shot, and then we'll get going. So first up, the equation of the axis of symmetry. So the equation of the axis of symmetry should be, if you remember, -b over 2a. Now this is calculator free, and because it's calculator free, that means you have your own, sorry, calculator aloud is what I meant to say. Because this is calculator aloud, you are allowed your own notes. You should know this formula for the axis of symmetry. So b is 12, so -12. A is 3, so it's 2 times A is 6. The axis of symmetry is -2, so x equals -2 is our equation for the axis of symmetry. Or if I was to sketch that, that will be the axis of symmetry -2. Oh, sorry, not +2. What was I doing? Wrong side. -2 is on this side. So the axis of symmetry is x equals -2. So the graph of y equals ax squared plus bx plus 13 passes through these 2 points. Determine the values of the constants a and b. So now let's have a look at this one. So what we know here, and in fact this one is a simultaneous equation question. So we have been given 2 values for y, or for our y values and our x values. So we're going to need to be using our simultaneous equation solver, and that, if you don't know where to find it, let's get back into main. That is this little one here. Let me clear all these. So this is the simultaneous equation button. It's this one here, and that allows us to solve a simultaneous equation. So let's make that up. So y equals ax squared plus bx plus 13. Y equals -3. Oh, sorry, x equals -3. So I'm just going to put that in here, and I'm going to use my variables here. So if y is -23, so I'm just going to write that, -23 equals -3, and make sure a -3 squared plus b times -3. Make sure you got your brackets here. That's one equation. My second equation is going to be 5 equals a times 4 squared plus b times 4 plus 13. So let's put these into our calculator. So -23 equals a times -3 all squared plus b times -3. And let's put that in brackets just to be safe. And then add 13. And then we've got 5 equals a times 4 squared plus b times 4 plus 13. And then we've got to tell it what variables we're working with. We're working with a and b. Now let's just double check that I've got that correct. -23, a times 3 all squared, -3 all squared, plus b times -3, take 13, plus 13. That all looks good. And they won't usually try to trick you with these. So if you get, with these complex ones, so if you get some integers, then you should be fairly confident that you've done the right thing. So, and you can always sketch this as well. So I'm going to try writing that -2x squared plus 6x plus 13. Let's get that answer at the front. So if I was to try to sketch that up, let's find, if I do a G-solve, I want to find y when x is -3. Y is -23, as expected. Do another G-solve. Calculate y when x equals 4. Y is equal to 5. So I have conclusively sorted out that the answer is a equals -2, b equals 6, and that's all. Now, where you're getting your points is accurately substituting this. It is okay to say that I used simultaneous equation solver. To get those two, but because part of the marks you're getting is being able to accurately enter those into your calculator. It's completely fine. This is how you are expected to solve it. You do need to know how to use the graphics calculator to be able to do that. So there we go. Now that is that's a good chunk of our marks for our calculator allowed and our calculator free section. So that is 17 marks for the calculator calculator allowed and 16, I think, marks for the calculator free. Yeah, hopefully you've gotten a bit out of that. I hope you managed to give those a shot before having a look at the answers that I provided you, but we've got that there as well. So that was question 1, 2, and 3 of the calculator free, and questions 9, 12, and 13 of the calculator allowed. So you should be able to have a look through the exams, past exams, and find some other questions you should be able to answer, but we'll be having a look at those again in the future. So anyway, hope you've enjoyed that. Hope it's been useful to you, and have a great day.